Today we're going to go ahead and talk about the mole and how we can use it in certain calculations, specifically conversions. Okay, so one thing that I want you to understand is that this number, which is we call Avogadro's number, is the same as this number. This just happens to be set up as scientific notation, whereas this is in standard form. We put it in scientific notation because it's a lot easier to write it like this because it's shorter than for us to write it with all the zeros trailing behind it. And if you notice, it's not that you necessarily have 23 zeros, but you're going to shift the decimal until you only have one number in front of that decimal point. So we had to also include that 2 all the way up to behind the 6. Okay, so 1 mole of anything, and I do mean 1 mole of anything, any element, anything, it doesn't matter what it is, it's equal to that number, 6.02 times 10 to the 23rd. Okay, that mole could be atoms, it could be molecules, formula units, representative particles. We use these depending on what it is that we're working with. So if it's just like an element on the periodic table, then we would say that 1 mole of whatever substance is equal to that number atoms. If we're working like with molecules such as water or carbon dioxide, then we can just add the word molecules behind it. It really doesn't matter. You can use these words interchangeably as long as you use them correctly, but they're all going to mean, or they're all going to be the same amount, which is 6.02 times 10 to the 23rd. Okay, you're also going to be doing this when we do the math. It's called dimensional analysis. It looks like a bunch of boxes, and pretty much what you're doing is you're putting all your numbers on those boxes. But just so you know, the given always goes in this box, and this one is always going to be blank. Okay, so there's never going to be anything in this one, but everything else you would fill out. And you don't necessarily will have this many boxes. Sometimes you'll have less. So that means you won't have these, or sometimes you'll have more boxes. It just depends on the type of problem that you're doing. And another thing you need to remember is that whatever the units are, like if the units, for example, were grams, then they'd have to be the same diagonally, grams and grams. And the reason we do this is so that we can cancel units out, and that allows us to get the answer correctly. And you're going to find out that when you do this, or you go on to physics, you're going to do this a lot. So again, the units should always match diagonally. So if this is grams, that would be grams. So let's say we have moles here, then that means that diagonally, this would have to say moles as well. Okay, so another thing that I want you to know is that when you're dealing with grams or mass, you're always going to use the one that's found on your periodic table. And you're going to find the mass based on the element or atom that is given in the question. And just so you know, that the mass of every element or any element on the periodic table is always going to be equal to 1 mole. So what I did is I highlighted a few of them. So as you can see here, this represents the mass. So we would say, for example, that for magnesium, 1 mole of magnesium would be equal to 24.305 grams. Here we could say that 1 mole of calcium would be equal to 40.08 grams. So each of these is specific to the element, and they're all going to be equal to 1 mole. Okay, so for our first example, which you have it there, it's going to ask you how many molecules of carbon dioxide are in 14 moles of carbon dioxide. Okay, so once again, we're looking at the first example that's given to us. First of all, because this is more of a starter type of assignment, you're going to see that some of it is kind of started for you. There's examples, but I'm going to take you to the process of how we got to that point. Okay, so in this case, you're always going to start with your given. I'm going to tell you right now that for all of your dimensional analysis, you'll be using something that looks like this across. You always start that way. You're never going to write anything in this bottom first box. this one on the top is always going to have your given. And for those of you that don't know what a given is, it's the only given number or numbers in the question. So in this case, it's 14 moles of CO2. So that information goes in here. All right, so it's going to look like this. And by the way, the abbreviation for moles is MOL. I know it seems silly, but that's what it is. Okay, so I'd like for you to put all the information because this is going to help us with the dimensional analysis. So notice I didn't cut corners and I did not just put the number 14. I actually went ahead and put that there's 14 moles of CO2. Okay, so when you're doing dimensional analysis, you need to keep in mind that everything should be diagonal, as I mentioned before. So if this is moles of CO2, that's got to be moles of CO2. The other thing that was mentioned before is that you have to remember that 1 mole of anything, in this case 1 mole of CO2, is equal to 6.02 times 10 to the 23rd. And it's going to be any of these words that we can use behind this number. Now, we're not going to just randomly pick. We're going to obviously use the word that's given to us in the actual question. So if this were atoms, then we'd use the word atoms right behind Avogadro's number. But because this says molecules, that's what we're going to use. Okay, so it is safe to say, which I'm going to write down here, that in 1 mole, and remember I said of anything, in this case of carbon dioxide, it's equal to 6.02 times 10 to the 23rd, and in this case we're going to also use the word molecules. Okay, so now the important thing with this is to be able to put it into these two boxes. I want you to consider this as one thing and this as another thing. Okay, so the question is, there's 2 items that we need to put into these 2 boxes. So which one goes where? Well, think, if this is moles of CO2, and I did tell you before that the units have to match, you're going to have to put this one because molecules does not match moles. So it's got to match as the same unit. So I would put 1 mole of CO2 here on the bottom, and on the top I'm going to put the one with Avogadro's number, the 6.02 times 10 to the 23rd molecules. Okay, once you have that, that means that you can go ahead and cancel the like units. So this is the same and this is the same. We would cancel those. We don't cancel the numbers, just the unit and the substance. And then now we can go ahead and see if whatever our remaining unit is what we want in our answer, which it is. It's asking for how many molecules. And if you notice, the top last unit is molecules. So that means that we're done with the dimensional analysis. That means we don't have to create more boxes and we can actually close it off right here. For the math portion, we're going to go ahead and multiply in the following way. Just kind of remember a little rhyme that goes like this. If the numbers are side by side, you multiply. So side by side, you multiply. And if the numbers are top and bottom, you divide. So side by side, you multiply. Top and bottom, you divide. So in this case, we're going to multiply 14 by 6.02 times 10 to the 23rd. Whatever answer I get from multiplying those two numbers, I divide by 1. And we know that anything multiplied or divided by 1 is the same answer. Okay, so I'm going to go ahead and show you how to do it. Okay, so to put this information into the calculator, we're going to start with the 14 moles. So we're going to type in 14. And then since they're side by side, we're going to multiply these two. So it's going to be times. Okay, to enter this into the calculator, there's a button that I'm going to ask you to learn from here on because it's going to be a lot easier to do the work. We're going to type in 6.02. So 6.02, just like that. Instead of typing in times 10, we're going to use this button, and that takes care of the times 10. It's the one that has a double E. And so when we look at the screen, it gives us an E. So that E means times 10. And then we have to now put what's left over, which is a 23, which is an exponential value. So 23. Okay, once you do that, you can go ahead and click enter. And this is what you get. You get 8.428E24. This is not how you want to write it on the paper. You actually want to write it in scientific notation, but the E is more of a calculator language. So when we write it, we can go ahead and round to the nearest hundredth. That means 2 numbers after the decimal. So it's 8.4. And then we're going to, instead of just putting the 2, we have to look at the third number, the one behind the 2. It's an 8, so it's greater than 5, so it makes this 2 into a 3. So 8.43, and I'm going to stop right there. The E is interpreted as times 10, and then the 24 means its exponential value, so it's to the power of 24. Okay, we're almost done. That's a numerical answer, but now we have to put a unit behind the answer. Remember that we canceled the moles of CO2? That was that unit we canceled, but we're left with molecules. So we're going to go ahead and write down molecules. And we can go as far as saying that it's molecules of CO2. So molecules CO2. Okay, and that's how you would do this first one. Okay, and for the next question, there's occasionally going to be questions where they're asking you a part of the compound, not necessarily the entire thing. Like this one is asking how many atoms of potassium are in 3 moles of potassium sulfide, so K2S. Okay, when this happens, we're going to have to find out first how many moles of just potassium we have. Okay, so it reads there, this question is asking only about potassium, but you're given the information about the compound. So you'll have to first calculate the number of moles of potassium. Okay, so that means that we've got our 3 moles of K2S. Okay, and then I know that in 1 mole of this K2S, there's 2 moles of K. That's because I can tell that there's a 2 there. That's why I know it's 2 moles. So now, to do the math, I'm going to multiply the 3 by the 2. So side by side they multiply. That's 6 divided by 1, giving me 6 moles of, and this one doesn't have it, but we're going to add it on here, 6 moles of K. Okay, so now that we have how many moles of potassium, that means that we can now calculate the atoms of potassium. So I've got 6 moles of potassium. Remember that 1 mole of anything is always Avogadro's number. So just like we said here before, it's going to be the same thing. So 1 mole of potassium is equal to 6.02 times 10 to the 23rd. And notice that now the magic word here is atoms. So unlike the previous example we used molecules, we're going to use atoms here. And I can go ahead and put atoms of K, just like I could have put atoms of CO2 in this previous one. Okay, so now that I have this conversion factor, remember this is one thing, this is a second thing. I've got 2 boxes, so I've got to decide where each of those is going to go. Because this reads as 1 mole, and that's moles, I'm going to go ahead and put the 1 mole on the bottom, just because it'll cancel diagonally. So I could put 1 mole of potassium. That means that the other part of it is this number, which is going to go here on the top portion. Okay, so atoms of K. All right, so this unit cancels with this unit, and now we have the number 6. we're going to multiply because it's side by side by Avogadro's number, and we're going to divide by 1. So just the same way you did on the calculator before, you're doing the same process. Okay, go through the entire assignment. You're going to find that you have examples for each section. Go through those examples, and that's going to aid you with going through the entire worksheet. If you need any help, you let me know. If you have any questions, just let me know.